Good day, everyone. I'm Jurosely Girina. I'm your first reporter for this lesson is all about inductance and our learning objectives. By the end of this lesson, you will be able to understand the basics of inductance, to identify the factors affecting inductance, to be able to obtain the self-inductance and mutual inductance, and to apply inductance in real life. Okay, what is inductance? Inductance is a property of a conductor that is measured by the size of the electromotive force or voltage induced in it, compared with the rate of change of the electric current that produces the voltage. And inductors are typically used as energy storage devices in switch mode power devices to produce DC current. The inductor, which stores energy, supplies energy to the circuit to maintain current flow during off-switching periods, thus enabling topographies where output voltage exceeds input voltage. Take note that a property of an inductor is inductance, that opposes any change in magnitude or direction of current flowing. The larger an inductor's inductance, the greater the capacity to store electrical energy in the form of the magnetic field. And let's go beyond inductance. And inductance is caused by the magnetic field generated by electric currents flowing within an electric circuit. Typically, coils of wires are used that increases the coupling of the magnetic field and increases the effect, as we see in the picture. Okay, to deepen the inductance, L represents inductance and Henry is the international system unit of inductance. The inductance value represented L is an honor to Heinrich Lenz, and its unit is Henry. 1 Henry value is equivalent to the induced 1 volt by changing of current in 1 ampere per second in an induced value. And who is the one who discovered the inductance? It is Joseph Henry. An American physicist developed one of the first electromagnetic motors and pioneered the manufacture of strong functional electromagnets and discovered inductance. As we all know, in the electric current flowing through an inductor create a magnetic field around it. So, during his experiments with electromagnetism, Henry discovered the property of inductance, which are the self-inductance and mutual inductance to be discussed later, and which was first recognized at about the same time in England by Michael Faraday in the previous lesson, who was the first to publish on the subject. In honor of Henry, the International System Unit, which is Henry, bears his name. And while working with this powerful electromagnet, Henry first observed the inductance. This property of a circuit is observable when varying on magnetic field generates electromotive force or voltage.
Hello everyone, good afternoon. I am Eunice Bingocaster from BestEd. And I'm here to discuss the unit for measurement and the factors that affecting inductance. So let's talk about first the unit for measurement. By measuring the inductance, we should use a ohmmeter to find out the number of the inductance in a coil, and the name of that unit is called Henry, which it follows to the person who discovered the inductance, which is Henry Joseph. And there are 4 factors affecting the inductance. First, we have number of wear turns in the coil area, core material, coil length. So let's talk about first the number of wear turns in the coil. Inductance is greater when the number of turns of wear in the coil is greater. More coils of wires indicate a greater amount of magnetic field force for a given amount of coil current. So it affect the wire turns in the coil. So if marami yung wire turns in coil, so the inductance is tumataas. Kumbaga, nag-i-increase, greater. Okay, then, second is coil area. So, isa din ito sa mga nakaapekto sa, kumbaga, sa inductance. Okay. Inductance is proportional to the coil area. Greater the coil area, the greater the inductance. Greater coil area presents less oppositions to the formation of magnetic field flux for a given amount of field force. So, sabi nga dito, if the coil area is malawak, kumbaga greater, then the inductance is greater also. And third one is core material. The greater the magnetic permeability of the core to which the coil is wrapped around, the greater the inductance. So, kumbaga, if the coil is, kumbaga, nababalutan, then the inductance is nag-i-increase. And then, last one is coil length. The longer the coil length, the lesser the inductance. The shorter the coil length, the greater the inductance. So, nakaka-apekto din ito sa inductance itong coil length. If the coil length is longer, sabi nga dito, if the coil length is longer, the inductance of that is less than. And then if the coil length is shorter, then the inductance is greater. So, thank you and God bless.
Good day, everyone. I am May Andrew Ipantaliano, and I am the assigned reporter of this part. So, there are two types of inductance, the self-inductance and the mutual inductance. So, first, the self-inductance, which states that when there is a change in the current or magnetic flux of the coil, an electromotive force is induced. This phenomenon is termed self-inductance. When the current starts flowing through the coil at any instant, it is found that the magnetic flux becomes directly proportional to the current passing through the circuit. When an AC passes through a solenoid, the magnetic flux linked with it changes. This flux change induces an EMF in the solenoid. This EMF opposes the EMF in the circuit. Due to this, the voltage in the circuit also decreases. So, the intensity of the bulb also decreases. This phenomenon is self-induction. Self-induction is that phenomenon in which a change in electric current in a coil produces an induced EMF in the coil itself. The EMF due to self-induction is opposite in the direction of the current in the circuit, so this EMF is called back EMF. So the formula of self-inductance is L equals N times the magnetic flux over the current in amperes, where L is the self-inductance in henries and N is the number of turns. On the other hand, mutual inductance is an inductive effect causes a change in voltage across a second circuit as a result of a magnetic field that links both circuits. Considering the two coils, the P coil or the primary coil and S, which is the secondary coil. A battery and a key are connected to the P coil, whereas a galvanometer is connected across the S coil. When there is a change in the current or the magnetic flux linked with the two coils, an opposing electromotive force is produced across each coil, and this phenomenon is termed mutual inductance. When the strength of the current in one of the two adjacent coils changes, a change takes place in the magnetic field around. As a result of this, an EMF is induced in the second coil. Thus, this phenomenon is mutual induction, in which the EMF produced due to mutual induction and the number of turns in the coil are interrelated. If we increase the number of coils in the secondary, the intensity of the bulb also will increase. If we cut down the number of turns into a half, the intensity of the glow also decreases. From this, we can conclude that there is a relation between the EMF produced by mutual induction and number of turns. So the formula of mutual inductance is M equals to mu O times mu R times N1 times N2 times A over L, where mu O is the permeability of free space, mu R is the relative permeability of the soft iron core, N is the number of turns in coil, A is the cross-sectional area in M2, and L is the length of the coil in M.
Induction comes into play when there is a interaction between the magnetic field and the current carrying conductor. In self-induction, it happens when there is a interaction between the conductor and the magnetic field produced by the current na dumadaloy dito. On the other hand, the mutual induction happens when there is a interaction na nagaganap between one conductor and the magnetic field that is generated in some nearby conductor carrying current. So there are a lot of use of inductors, some of which is in tuning circuits, sensors, in a device, motors, transformers, filters, chokes, ferrite beads, and as a relays. The first thing that we are going to discuss is the inductors being used in a tuning circuits. So with the help of inductors, the turning circuits can pick the desired frequency. Capacitors and inductors are used in a variety of electronic devices such as radio tuning circuits, televisions, and other electronic devices to adjust the frequency and assess in frequency solution across several channels. Another use of a inductor is it can be used as a sensors. So the inductive proximity sensor is a contactless sensor that is particularly reliable in operation. The magnetic field in the coil opposes the flow of electric current, which is the primary idea behind it. Like in the traffic signals, proximity sensors are used to detect the traffic density. Inductors can also be used to store energy in a device. So inductors can store energy for a small period of time because the energy stored as a magnetic field is lost when the power supply is disconnected. Uses of inductors can be seen in computer circuits where power supplies can be switched. Moreover, inductors can also be used in induction motors. The presence of magnetic field produced by alternating current causes the shaft in an induction motor to rotate. The frequency of the source's power supply can be used to adjust the motor speed. The motor speed can be adjusted by incorporating inductors. Inductors can also be used as transformers. A transformer can be created by combining many inductors with a common magnetic field. One of the most common use of transformer is in a power transmission systems. As step-down or step-up transformers, they are used to reduce or increase the power transfer. Inductors are also used as filters. So, filters will be created by combining inductors and capacitors. The frequency of the input signals as it enters the circuit is limited by the usage of these filters. The resistance of the inductor increases as the frequency of supply increases also. Another thing, it can also be used in shocks. We already know that when AC current runs through inductors, the current flows in the opposite direction. The inductor then chokes the AC current flow while passing the DC current. This mechanism is utilized in the power source to convert the AC supply to a DC. Furthermore, inductors is also used as ferrite beads. Ferrite beads have been observed in computer parts and mobile phone charging connections. Inductors in a ferrite beads help to reduce the frequency of the radio interface created by the cable. Lastly, it can be used as a relay. A relay functions similarly to an electrical switch. When an inductor coil is used in switch, a magnetic field is created anywhere the switch comes into contact with AC current flow.